A spacecraft can be alive and still lie to you. Voyager can keep its antenna pointed, receive commands, and transmit a clean radio carrier. Yet the information inside the stream can turn into impossible numbers and meaningless patterns. That's ghost data, contact without truth. Tonight we show how this happens, why it looks supernatural, and how engineers proved it was an old computer problem, not space magic. Voyager 1 is a 1977 spacecraft still operating far beyond the planets, running on tiny power budgets and 1970s computers. It survives by doing three things: stay stable, package telemetry, and whisper it back through NASA's Deep Space Network. At this distance, the signal is faint, the bandwidth is microscopic, and small failures become cinematic. Most impossible signals aren't the radio wave itself. The carrier can be perfectly detectable while the bits inside are corrupted. Think of it like hearing someone speak clearly in a dark room, but every sentence is nonsense. Deep space mystery often comes from decoding, not detection. Voyager's normal downlink is extremely slow by modern standards, on the order of hundreds of bits per second in typical modes. When your entire health report is a trickle, one corrupted word can destroy the whole picture. A small fault doesn't reduce quality, it can erase meaning. In November 2023, Voyager 1 began sending back engineering and science data that Earth couldn't interpret, even though the spacecraft was still communicating in other ways. NASA teams could command it, but the returned telemetry looked like gibberish. That's the nightmare scenario. The patient is awake, but the monitors are lying. NASA identified the problem in the Flight Data Subsystem, FDS, the computer that packages data before it goes through the telemetry modulation unit and radio transmitter. So the transmitter could still broadcast, but the story being packaged was broken. That's the nightmare scenario. The patient is awake, but the monitors are lying. Telemetry is structured numbers, temperatures, voltages, states, counters. If memory is corrupted, the packaging code can misread bytes, shift fields, or repeat patterns. The result is impossible values, not because physics broke, but because bookkeeping did. Ghost data is basically the spacecraft reporting reality through a torn dictionary. NASA, JPL reported the team found a single chip storing part of the FDS memory, including some software code, wasn't working, making the data unusable. That detail matters. This wasn't a vague signal anomaly. It was a specific hardware failure with a specific symptom. Voyager is decades past its design life. Components age, radiation can flip bits or gradually damage memory. Even without a dramatic event, long exposure plus time can produce failures in old chips. In deep space, the line between glitch and permanent damage is thin. Engineers can't interact in real time. Every test is, send a command, wait, see what comes back. That forces surgical decision-making, minimal risk diagnostics, tiny steps, and constant fear of pushing the system into an unrecoverable state. On Earth you reboot, reinstall, replace parts. On Voyager, power is scarce, memory is tiny, and some systems must stay stable to keep the antenna pointed home. Lose attitude control or communication lock, and you don't get a second chance. So the fix must preserve the few functions that still work. JPL explained they couldn't repair the failed chip, so they moved the affected code elsewhere in memory, but no single free block was large enough, meaning they had to split and relocate sections strategically. That is ghost data exorcism, restoring truth by rebuilding the pipeline around dead memory. First you restore engineering telemetry, basic, vital signs. Then you verify stability. Only after that do you rebuild science data pathways. That's why ghost data doesn't vanish instantly. You don't flip a switch. You reclaim functionality piece by piece. First you restore engineering telemetry, basic, vital signs. Then you verify stability. Only after that do you rebuild science data pathways. That's why ghost data doesn't vanish instantly. You don't flip a switch. You reclaim functionality piece by piece. Voyager has faced prior incidents where a subsystem sent garbled status data and engineers corrected it while still investigating root cause. So the pattern is known. the spacecraft can be functioning while its reporting channel becomes unreliable. When telemetry breaks, you lose your dashboard. You can't trust temperatures, voltages, or status flags. That uncertainty feels like something unknown is happening. But the real horror is simpler. You're blind, and the spacecraft is too far away to inspect. Many space mysteries are engineering mysteries wearing a cosmic costume. Low bandwidth, extreme distance, old hardware, radiation, and long delays. You don't need aliens for something to look impossible. You just need one memory chip to fail in the wrong place. Voyager's ghost data is proof that a clean signal isn't the same as a true message. The carrier can be perfect while the data pipeline collapses. And yet engineers can still diagnose and patch a 1970s system from billions of kilometers away by rebuilding logic around dead memory. Subscribe to World of Mysteries for more evidence-first investigations.